Hey guys, today this is going to be a rant video about um basically best practices in the software industry. Now I've been in the industry for quite some time, 15 plus years, and I started out my career by programming in Java. Incidentally, even in college when we did our operating systems, we did the Nachos uh, educational OS in Java, and I was at one point definitely very much a person who would be um, you know talking about like C++ being a bad language and Java being a much more cleaner version of it, etc. Trading some performance for basically putting a lot of guardrails and leading to code which has easier maintenance, etc. uh, I also saw this with large applications in mission critical domains like billing and commerce, and things were all fine. And then gradually I started seeing bigger and bigger systems and code which was written uh, often grew organically. And yeah, people in the industry come from different backgrounds, and then they read up all kind of things, etc. And then all kind of design patterns and various patterns emerge. This One of the things in the Java land which we have seen a lot is shallow classes, a lot of small classes, too many classes, long names, a lot of boilerplate code. This all led to the language getting a bad name also. And when functional programming came in other languages, uh, like in some JVM languages also, like let's say Scala, or other languages which had much little um, boilerplate code, say Python or Ruby, etc., languages which were expressive, um, that took a lot of share away from Java. Even though Java had its own strengths of great support with the IDE, etc., like um, you know being able to do a lot of big refactorings and mature code bases, mature libraries, etc. Uh, so people would continue to invest there, big companies. And some of the work, like let's say where you have to do data science, etc., that started going to other languages like Python. That has been the trend. Recently I was asked about like some let me bring this up. Yeah. I was asked about a hypothetical, let me cut out some PII information here. Yeah. So yeah, I was asked about some kind of scenario based question, that we have a e-commerce application which has integration with various payment gateways. It's a Spring Boot microservice, and it's a single monolithic service, and it does like all kind of things: request processing, talking to payment gateways, maybe order placement, this that, reconciliation maybe. So it's all happening in a single class. What do you do? Uh, the the answer which would please the interviewer is slightly different from what I would actually do in real life. Because see, this question is uh, you could answer it in different ways in different scenarios. Suppose you've got a fast moving company, right? Some startup where everything has been put in into one class, everything is still growing, etc. And then come in as a lead and you say, no, this is just a big ball of mud, and you want to refactor it into, say, 25 classes. Now, does it does it work? Does it still work? Have you introduced any new bugs? Right? Uh, that's the first thing. You'll have to spend time in testing, automated testing, regression. Uh, you know, to ensure that you have actually done this the right way. You have not traded any correctness, and also not traded any performance. And God forbid if you ended up doing microservices, then you will have like problems, which would show up, like you'll have issues in observability, you'll have like distributed transactions, and maybe you'll have traded off simplicity for eventual consistency, semantics, and whatnot, right? So, and your deployment, etc., will also be more complex. So, does it make sense for a startup to do it? Most likely not, right? Because they generally are in the process of making rapid changes, perhaps multiple times a week, and deploying things, etc. Um, but at the same time, if it is a company which can perhaps plan to run the current code as it is, and then work on this re-architecture, right? Maybe stand up a secondary system, then you can look at this question in a different way. So that context may need to be added. And if you have the freedom to bring up, like, this is something which I was witness to in Google's rewrite of the Moneta biller, which was heavily tied to AdWords. And then we basically had this rewrite spanning 3 years, team of more than 100 engineers, and across 7 subsystems, 7 shards. And basically, after you do this, then you basically have to prove correctness, and then you slowly and slowly migrate, right? So it's a long process, right? And usually these kind of rewrites, they are all very tricky, and nobody can really foresee the issues which can happen, right? And then they bring in a lot of additional unknown unknowns, and their costs, etc., right? So whatever is the promise of the rewrite, it should be quite clear what are we trying to even, like, you know what is our north star. In the case of the Moneta biller, it was a new billing 3.0 billing 3 system, which was supposed to work for all Google, um, all Google products, and which worked out great. Like, after AdWords, the next system they integrated was actually Google for Work or Google Enterprise, and perhaps more, right? So it made sense for a company like Google to have a huge investment like that, because the product was growing, and they just needed to, like, have a better billing platform. They wanted a platform solution, right? For a smaller company, this may not make sense. Sometimes engineers try to do this kind of thing, that, yeah, we will, we'll create all these packages or classes, etc., single responsible. So we have these solid principles, right? Solid principles by Uncle Bob is quite well known. Let me just look up solid principles here. So you have the single responsibility, every class having single responsibility. So clearly um, the class which we are talking about, that doesn't have a single responsibility, so you'll end up with, like, maybe like a dozen of classes. You have the open closed classes should be open for basically extending it, etc. So which means you will have, like, some kind of class hierarchy, inheritance, all that. Now inheritance is a tricky thing, right? Like, often, like, I read the Effective Java series of books, and there is inheritance versus composition, etc., and inheritance can be very powerful. At the same time, it has its own issues. So look at Effective Java for that. Why you may not want to introduce your inheritance hierarchy very early without really understanding if you have a true inheritance hierarchy. Liskov substitution, again, it's about like tied to inheritance. Interface segregation, again related to inheritance, right? Inheritance, or rather, like you can also say, yeah, inheritance with regard to interfaces, where you have a big interface and then you have smaller interfaces also, etc. uh, I kind of like interface segregation. I have done that a lot in the past, but you may end up with actually having a lot. What ends up happening is you may have too many interfaces, you may have interface hierarchy, etc. You may have a lot of your tests where you basically create mock version based on interfaces, mock implementation, etc. Everything seems to feel like, yeah, it is all improving, but you know if you don't have good acceptance tests, automated end-to-end tests, etc., you know I don't think that you should really treat it like as having more unit test coverage, etc., as a signal for better system, right? So be careful about that. And then, yeah, there is dependency inversion also in there. uh, Higher level module should not depend on low level modules. Both should depend on abstractions, interfaces. I forget what is dependence inversion. Yeah, there's some stuff here. Again, so this kind of stuff, right? Like often just taking some principle and then quoting it, etc., uh, and letting that run havoc in your code base without really having any metrics or north star of what business actually wants, right? That is a recipe for disaster. Every decision should be seen as a trade-off. You can improve code quality, you should measure code quality. There are like this, say, cyclomatic complexity, etc., or you can have other proxy things, like what is the like if you have some classes which are too big or methods which are too big, etc., right? So those are all proxies. Sometimes there are exceptions, but use these as rules of thumb, right? That is where the experienced engineers, senior engineers, they have seen like years of investment into refactoring, or basically doing things uh, just for the sake of doing them in isolation, without any you know like consideration for what is the business requirement here. So this often leads to yeah, risky adventures and you know unmet promises. So you should guard against that. So yeah, I just wanted to talk about this briefly, because this is a vast topic. uh, I also quoted Deep Classes by John Osterhout, um, like where which is kind of the antithesis to single responsibility, uh, or rather like shallow classes. Let's not say single responsibility, because deep classes can also have single responsibility. It's basically just a way to think that, yeah, a class should have very specific contract, let's say, and all the implementation aspects could be like as private implementation within the class itself. So the class kind of stands on its own, right? So whether it is a class, whether it's a package, uh, but basically having conceptual uh, you know entities in your code base, whether it is packages or classes or whatever, right? Having them represented at the right granularity is very tricky. So yeah, basically I would say this takes time. And what is the really bad thing which is happening now with AI generated code? Let's talk about that for a couple of minutes. My feel about this is uh, it the generative AI, it basically kind of mimics or learns whatever we may want to use here, but it is going to give you a distribution similar to the input distribution, right? So if the code it is trained on has a lot of this uh, clean code stuff, right? Then you will get a lot of clean code as output, right? And the AI will basically, if you try to reason with it, it will reason in those principles, right? uh, you have to be careful about this, right? Because nowadays it is very easy to as somebody said, right? AI is now like a Formula One car. No, actually, that was in a different context, but yeah, basically, you can apply the same analogy, right? Let's say you would earlier write code in C, header files, implementation, everything. You're kind of doing very low level coding. Then you could work with better tools, IDs and whatnot. You could have some help on code generation, scaffolding, this, that, maybe in a typical Java development kind of space, or with some uh, other techniques which allow you to generate code, right? Let's say we talk about like protocol buffers and whatnot, right? Generates a lot of code, service interfaces, mock implementations, all of that, right? This increases your productivity, but still the way you design and think about things is largely your own. Then comes in AI, and then AI has uh, started influencing how we think about software also, right? By actually generating a lot of the code and also influencing design decisions. And the engineers who are fairly new to the game, right? They may treat what the AI is talking about as gospel, because we have the authority bias. I've talked about this in various conversations with Pavan also, right? So they may treat it as authority bias, and then with due to authority bias, and basically they will trust it, etc. And then they will think, yeah, yeah, this is all great. And then the issues which will they will run into, right? They will manifest only after the code has grown a lot, right? And then they'll try to figure out strategies to manage whatever has become an issue, right? So uh, yeah, so then maybe certain things may become necessary, and it may completely go out of your hand also. So be careful with you know and yeah, another thing is, I agree that you I've been in places where we do a lot of really clean looking code, but the performance is really, really bad. And another thing which is uh, in the news on and off recently is about security issues which can be there um, with AI generated code. So yeah, how you kind of use AI in real uh, production code, etc. Uh, yeah, just don't trust whatever the AI produces, because AI is learning from whatever people have written, and people have generally written bad code, right? Code which has lived for a very long time. Maybe it is the code from the 80s, 70s, 80s, etc. Unix code, a lot of the you know early code which is there, like TCP/IP code, etc. And you know those things are predating a lot of the various principles which have come in and have become very popular. They have become a little less popular with functional programming, but again, now uh, with AI and AI picking up from a lot of the generated code, this may become something which we can see on the rise. So we don't want to be repeating our mistakes also. Thank you.